Hi everyone, in this project my goal was to develop a high performing classifier for the UCI bank marketing dataset and to maximize the ROC AUC score on the cargo leadership board, while ensure that the model is well fitted and not overfitting. In this presentation, I will discuss two main aspects of my work: what I did to improve the performance of my model, and what I did to access and improve the model fit. To improve a model performance, I focus on three main strategies: selecting a strong model, using cross-validation, and applying model embedding. Instead of using a simple model such as logistic regression, I choose light GBM, which is a gradient boosting decision tree algorithm. Light GBM is particularly effective for tableau datasets like the bank marketing datasets because it can capture nonlinear relationship between variables, performs well with category feature, and is more optimized for large dataset and high predictive performance. The model was configured with several tiered parameters to balance complexity and generalization. For example, I use a relative low learning rate of 0.01. Let me check where is it. Yeah, over here. To allow the model to learn gradually and improve generalization. And I use 5,000 estimators so that the boosting process could build many trees while learning slowly. I also set the parameter number limit to 63 to allow the model to capture more complex patterns in the data. In addition, I use sample and co-sample B-tree value of 0.8 to introduce randomness in both row and feature sampling, which helps reduce overfitting. I also applied regularization through the parameter reg lambda to further control model complexity. Together, this parameter should help the model achieve a balance between predictive power and generalization ability. To evaluate the model more reliably implies a straddle k-fold cross-validation. In my complexity, I use five-fold stratification ensure that the proportion of the target class is preserved in each photo, which is especially important for binary classification problems such as the marketing predicting text. For each sport, the model is trained on the training split and then evaluate the validation split, where predicted probabilities are generated and the ROC-AUC score is calculated. This approach provides a more stable and reliable estimator. Another strategy I used to improve model performance was an embedded training. Instead of relying on a single LGBM model, let me see. Yeah, over here. I train multiple models using different random seeds. For example, I use seeds such as 1, 7, 13, blah blah blah, etc. Because LGBM use randomness in progress, such as feature sampling and data sampling. Differences lead to slightly different model and the predicted patterns. After training this model, I average the predicted probability from all model to produce and the final prediction. This assembling process reduces prediction variability and usually improve performance on the leaderboard. Ensemble technique are widely used in cargo competition because They make the prediction more robust and stable across different data sample. The second the major aspect of this project was ensure that the model was well fitted. A good model should avoid both underfitting and overfitting. Underfitting occurs when the model is too simple to capture and the underlying pattern in the data, while overfitting occurs when the model memorizes the trained data and fails to generate two new data. To evaluate mode fit, I use learning curve. A learning curve plot the training performance and validation performance as the training data size increase. In my application, I used the learning curve function from the scalar learning library, and by observing the learning curve, I was able to understand how the model performance changed as more data training was used and whether the model generated well to ANSI data. So in addition to the learning curve, I also assembled the stability of the model by examining the AUC score across the different cross validation folds. In the score vary significantly from one fold to another, it may indicate that the model is unstable and overfitting to particular subsets of the data. However, in my experience, the AUC score cross folds are relatively consistent, which suggests that the model generates well across different training and validation split. So after evaluating the model using cross-validation and the learning curve, I trained the finally ensemble model using the full training data set. Each JVM model was trained with the optimized parameter and the prediction on the test dataset were generated. I then averaged the predict probability from all models to obtain the final prediction. This prediction will exported into a CVS file and up to the cargo for leadership board evaluator. And in the conclusion, the main technique I use to improve model performance and ensure good model fit or selecting LightGBM as a powerful gradient boosting algorithm, applying stratified k-fold cross-validation to obtain reliable performance estimates, using ensemble learning with multiple random seeds to reduce variance, and analyzing learning curve to access model fit and detect potential overfitting. Together, this technique help improve the ROC AUC performance of the model while maintaining a strong generalization ability. Thank you for the listening.